Okay, so lesson 6.3, ellipses. So an ellipse is an oval shape, okay? As opposed to our circles, these are the only two conic sections that we study in this chapter. Okay, so notice two very similar looking equations. X squared over a squared plus y squared over b squared equals 1. Now in the other one, notice that the only things that are changing are the values of a and b, or the placement of a and b. Now the a squared term is under the y, the b squared term is under the x. So first things first, a squared is always greater than b squared. That value of a, where the greater denominator is, determines what we call our major axis is. So when the larger number is underneath the x squared, we have a horizontal major axis. So the ellipse will be elongated on the x, longer on the x than it is on the y. When the bigger number is underneath the y squared, then we would have a vertical major axis. So the equation of ellipse are always equal to 1. Okay, and then what's different from a circle, not only is a squared greater than b squared, but a squared cannot equal b squared. Because if those denominators are the same, then the equation just represents the equation of a circle. Okay, so a couple defining points. Our vertices and our focus, okay, our foci is the plural, will always lie on the major axis. So if we have a horizontal major axis, then our vertices are going to be, if our center is at 0, 0, our vertices are going to be plus or minus a, comma 0. Because from my center, I extend a units to get to the vertex. If I have a vertical major axis, okay, well then the coordinates, so it's always a from center to vertex, but now I'm moving along the y-axis, so my y values are changing. The focus, and I'll talk about what the foci actually are on the next slide. So your focus from your center to your focus is your value of c. So if I have a horizontal major axis, then the coordinates of my foci are plus or minus c, comma 0. If I have a vertical major axis, then from my focus to my center, now I'm changing all my y values, so 0, comma, plus or minus c. This relationship here, b squared equals a squared minus c squared, that is what will enable us to find the foci and the coordinates, or maybe the coordinates of a vertex. All right, so if A is the distance from center to a vertex, C is the distance from center to a foci, well then what's B? B is from my center to what may differ in a given textbook. Okay, that would be the endpoint of my minor axis. Okay, we always know that B is smaller than A. And no matter which way I look at it, from my center to an endpoint on my minor axis, that'll be my value of B. Two things to add. The length of your major axis. So if my major axis is from center A units to the right, it would have to be A units to the left as well. So the length of that segment would be 2A. And then likewise, the length of my minor axis. So if B is my distance from center to the endpoint of my minor axis, well then if I extend B in the opposite direction, the length of that segment would be 2B. Okay, so what are the foci? The foci are 2 points whose sum of the distances from any point on the ellipse is always the same. So if this is length 1 and this is length 2, the sum of my lengths is always going to be equal to the length of my major axis. Okay, so it's about the foci. They're the fixed points that the actual ellipse is created. And this, where I found this, it says on the major radius, we call it the major axis. Okay, so depending on your resource, they could use different terms for that. Now let's look at some examples. All right, so determine the length of the major and minor axes. So when I look at this, a squared is always the bigger number. A squared is equal to 25, the bigger denominator. Not only is a squared equal to 25, it's underneath my y. So I know that my major axis is my y-axis. Okay, so if a squared is equal to 25, a is equal to 5. B squared is equal to 9, so B is equal to 3. So then my major axis is just 2 times the value of A. So my major axis has a length of 10. My minor axis is 2 times the value of B. So my minor axis has a length of 6. To determine the foci, I need this relationship. B squared is equal to A squared minus C squared. Plugging in what I already know, B squared is 9. A squared is 25. Solving that equation, I get C squared is equal to 16, so C is equal to 4. Now my foci have to lie on my major axis. So on my major axis, since it's vertical, my y values are changing. So the x coordinate of my center remains 0, and I probably should have started there. The center is 0, 0. Now, from my center, my y value of 0, I'm going up and down 4 units to get to my foci. So my x-intercepts occur when y is equal to 0. So when y is equal to 0, my resulting equation would be x squared equals 25. So I get x is equal to plus or minus 5. My y-intercepts occur when x is equal to 0. So when x is equal to 0, sorry guys, y squared equals 9. So when y is equal to 0, x squared equals 9, x is plus or minus 3. When x is 0, I get y squared is equal to 25, so y is equal to plus or minus 5. If I write those as ordered pairs, okay. Now let's check out a real simple sketch of this. So my y-intercepts are going to be the coordinates of my vertices, 1, 2, 3, 4, 5. So my center is at the origin, 1, 2, 3, 4, 5. My minor axis, the endpoints of my minor axis will be my x-intercepts, positive 3, negative 3. Now when we're sketching these by hand, we don't need to plot the foci. So there's my ellipse. You will not be judged on perfection with these, that's for sure. All right, and then part E, if we think about translations, how is this graph related to the one we just sketched? Well, it's going to be a translation. And it's going to be a translation 2 units to the right. Okay, that came from the minus 2 with the x, and 1 unit down. So what we're going to look at next is moving the center. So now instead of the center being at 0, 0, if I put the center at 2, negative 1, then all of my points would change. Okay, so right 2, down 1, everything would change. Okay, so now, like I said, I can change the center to be at any point. It doesn't just have to be at the origin. Okay, now this could also be written, okay, with my major axis as my vertical. Okay, I don't know what's going on. This would be over b squared. Okay, so it doesn't have to be, if I change the center, it doesn't have to be that the major axis is always going to be the horizontal. Find the equation of an ellipse with the center at 0, 0, a given vertex, and a minor axis of 4 units long. In addition, find the coordinates of the foci. Okay, so the easiest thing I can give you, plot the points. Here's my center. Here's my vertex. Okay, so from that, we know from center to vertex is our value of A. So my A value has to be 4 units, which makes A squared equal to 16. Furthermore, because my vertex is on the y-axis, I know that my major axis is my y-axis. Okay, so using my center centered 0, 0, so x squared plus y squared equals 1. Because my major axis, we determine that to be the y-axis, 16 goes underneath my y term. Now I need to find what b is equal to, and that's where this piece of information comes from. Recall that the length of the minor axis is equal to 2b. So we're given that the length is 4. That gives me that b is equal to 2. So b squared would have to equal 4 as well. So I know that b squared is equal to 4. So that's my equation. That's the first part. Now it asks for the coordinates of the foci. So the foci, b squared is equal to a squared minus c squared. So I have 4 is equal to 16 minus c squared. Rearranging the equation. Now when I take the square root of both sides and I simplify that, I get c is equal to 2 root 3. Okay, now a value like this, you're not meant to graph that, okay? But the coordinates of the foci, so the foci lie on the major axis, so I'm not moving horizontally at all. But from my center, I'm going up and down 2 root 3 units. So we can just leave it, because it's an irrational number, we can leave it like that. Find the equation of an ellipse with the given center, vertex, and again our minor axis. So I'm going to automatically start at the center, just plugging that in. X minus 3 quantity squared plus y plus 1 quantity squared equals 1. Okay, so a quick little sketch. I know 3, negative 1 would put me here. There's my center. Now the other vertex is at 9, negative 1. Get rid of this. Okay, so center to vertex always gives you the value of a. So if I started at x is equal to 3 and I end at x is equal to 9, my value of a would be 6 units. So that tells me a squared is equal to 36. Now, which one is my major axis? The vertex always lies on the major axis. So from the center, I moved horizontally to get to my vertex. So my major axis has to be the x-axis. So 36 is going to go below the x term. Right, we're given the same information as last problem. Minor axis, that's equal to 2b. That has a length of 4. B is 2. So b squared is also 4. Okay, so my 4 goes underneath my y. So there's my equation. Now to determine the foci, we come back to b squared is equal to a squared minus c squared. I get c squared is equal to 32. Perfect square factor of 16, so that gives me 4 root 2. Okay, so now to determine the coordinates of the foci though, remember that they're based off the center. So my center is at 3, negative 1. I'm not moving vertically at all, so my y coordinate stays the same. But now from my center, I'm going to go 4 root 2 units to the right and to the left. So I start at my center and I move according to the value of c. All right, so that's all the time I have on this video, but that should give you enough information to be able to attempt some of the problems in class.